Okay, that gets us through our graphing. Now we're going to look at a little bit of applications of quadratic function. So here it says there's a manager of 100 apartments, and they know that $600 rent per month. At that price, or that rent cost, all apartments will be rented. For each $25 increase, one apartment will not be occupied. One less person would be interested in actually renting that particular apartment. And so they tell us let X represent the number of $25 increases to the rent, and we want to figure out an equation that tells us the revenue. The idea is sometimes it's okay to have a couple empty apartments. We might still make more money by increasing our rent, even though we might have some apartments that are empty. So first we're going to find our revenue equation. Remember the idea for revenue. The revenue comes from, in general, the rent cost times the number of apartments that are actually rented. Okay, that's our general way we'd find our revenue. And so for this one, we'll call it R of X. Okay, we have our rent. Our rent starts at $600, but we're kind of questioning, should we increase it? And by intervals of 25. And X is how many of those intervals of 25, so we're going to increase by $25 times some X that tells me how many times I've increased it by $25. And then the number of apartments rented, well, if I just charge $600, all 100 of them will be rented. But every time I have an increase of 25, so for every X, we decrease our number of apartments rented. So we're going to say minus X here. Because if I choose to increase by 25 3 times, then I'm going to go down to 97 apartments rented. Okay, this gives us our revenue. Obviously, it doesn't have the cost. It's not our profit, but it's our revenue function. Okay, what rent will yield the maximum revenue? Well, to figure that out, we have to take a look at what's the maximum value. Now, with these, we could do, we could find our vertex, but since it's a problem with large numbers, a calculator is really helpful to do that, and we're going to let our calculators find the vertex for us. So we're going to go to our graphing screen, and we're going to put in our function. Okay, our function is 600 plus 25x times 100 minus x. Okay, and we want to go ahead and take a look at the graph of that. And I'm in a different window, which is not helping me much. So I'm going to go back to what you probably see, which is Zoom 6. Okay, which is nothing. There's a reason we don't see anything. Okay, we've got the fact that in general, our revenue is going to be around 600 times 100, which is $60,000. So revenue is our Y values. It probably makes sense to change this window so I see some of those values way up higher like that. So I'm going to go to my window. I'm not going to have a negative number of increases of $25. But I don't know how many I'm going to have. Maybe up to 10 is actually a good thing. Okay, maybe I'll want more than that. We'll just play it safe and call it 20. And then our Y values are our revenue. Hopefully we're not going to have $0 in revenue. In fact, we're saying our minimum should be $60,000. Because that would be the situation where I have $600 rent and 100 apartments rented. Okay, so if I put my $60,000 as my minimum, let's see if we can get higher than that. Maybe we can get up to, let's even go generous and put 100,000. Maybe that's not generous. Maybe it can be more. I don't remember. Okay, let's take a look at that graph. All right, so this has this curve. It is a quadratic, and look, we need to increase it by $25, even more than that. It's still going up. So I'm going to change my window, and I'm going to change my X values to have a lot more than that, and I'm going to go up to 50. All right, we do see we finally hit a best case scenario. A maximum revenue is way over here. So we're increasing by $25 several times. Let's calculate what this maximum value is. So we go to second calculate, and we choose maximum, and we do our left bound and right bound. And we do our guess. All right, now pay attention to what the variables mean. X is what I want to find. It's my number of times I'm going to increase by $25. That's what it tells me here. And it says 38 times is what I should do. And so what rent will yield the maximum revenue? Well, first of all, X needs to be 38, which means I need to have 38 increases of $25. So my rent would be 600 plus 25 times 38. If I calculate that out, 1,550, so 1,550 was what I should charge for rent that will give me my most revenue. Now, what is that maximum revenue? Well, let's figure out what the revenue is. We go back to here, or we go to our calculator, because it happens when you have 38 increases of $25. Our revenue is here. Our Y value is our revenue, which is $96,000, $96,100. That's our maximum revenue. Okay, that's the same thing as putting 38 back into the equation for X. Okay, we have one last problem to do. And so one other application. We've got this idea that quadratics can maximize something. We've got one last application, and that is our vertical motion. We've seen this a lot. Here's a refresher of the equations that go with it. Okay, the formula that we have here for the original one is if we are actually throwing something into the air. Okay, this gives us our height formula. Here's our velocity formula, how fast it's traveling at a particular time. So it says the formula, and it actually gives you the values somewhat put into that. Gives the height of an object tossed upwards where V naught represents the initial velocity, S naught represents initial height, and T represents time, just like we've been seeing all along. They put in the gravitational constant for you already. That's what this G is. And a golf ball is hit straight up from the ground level with an initial velocity of 72 feet per second. Find the maximum height that the ball reaches and the number of seconds it takes us to reach that height. So our initial velocity is 72, so we need to put that in there. So we've got this height equation that's found by negative 16t squared plus 72t. And then our starting height. Well, it's hit straight from the ground, so our starting height is actually 0. So we don't need to include that. We want to find the maximum height that the ball reaches and the number of seconds it takes to reach that height. When we're trying to find a maximum, we're trying to maximize, we want to find the top of the graph. It's a quadratic, so let's go back to our calculator. We could find our vertex. We could do negative b over 2a from that standard form. We could try and complete the square and write it in vertex form. But with our word problems in general, I tend to use my calculator, and you're welcome to do that as well. So let's put in negative 16x squared plus 72x. Okay, and we want to take a look at the graph of that. Okay, our last graph we did had our window very high up. This is not helping us. Let's go back to Zoom 6 to start with, Zoom Standard. Okay, here we're seeing some of the graph. The graph went up, came back down. We need to see the maximum height, so we definitely need to look up higher. Let's change our window with a larger max. I'm just going to go ahead and jump to 50. See if that's enough. Probably is too much. Oh, I'm wrong. It's not too much. All right, so we need to go a little higher with our window. We can make it go up to 100. And there we go. We see our full parabola. We want to know the maximum. Whenever the problem's asking for a maximum, we want to find that maximum. So let's calculate the maximum. Okay, I did that fast. Hopefully at this point you're good at this. Okay, our maximum has an x value of 2.25 and a y value of 81. What does that mean? Let's go back to the problem and look and see what the variables represent. The x is put in place of t, so that x is our time. The y is our height. It says how many seconds does it take to reach its maximum height, and what's that height? Well, it takes 2.25 seconds to reach a height of 81 feet. I believe we're in, yes, feet per second. So to reach 81 feet. Okay, that's how long it takes to get that maximum height of 81 feet. Okay, and then we have one last problem here where it's actually asking you, just like on the front page we wrote the equation of a line, now we're going to write the equation of a quadratic function. Okay, where our given information is a vertex and just a general point. So if we're given the vertex, it makes sense to go straight to vertex form. Why don't you pause this and try and write your own vertex form just using this information? Okay, we can type in f of x equals, now here's the thing, we don't know a. We do know it went left 2, so x plus 2 squared has a minus 5, so that went down 5, so minus 5 here. To find that a, we want to use this general point. Okay, we're going to put that in because that can give us these two unknowns and leave a as its last unknown. We can put negative 27 for f of x. We can put negative 4 for x. Then we can solve for a. Okay, adding 5 to both sides gives me negative 22 equals a times, I'm going to go ahead and do this, negative 4 plus 2 is negative 2 squared. So that's 4. If I divide both sides by 4, I get negative 22 over 4 for a, which is negative 11 halves. And so writing our function, come over here for room, it is f of x equals negative 11 halves times x plus 2 squared minus 5. Okay.